Welcome back, dear students. So today we are going to start a new exercise on rectilinear figures. Okay, and in this particular exercise we are going to learn only about quadrilaterals. Now, as I talked about quadrilaterals, let's understand what is the meaning of this. So quadrilateral is a closed figure which is formed by four straight lines. Okay, so it's a polygon, we can say. It's a polygon with four sides. Okay, now there are some special kinds of quadrilaterals that you need to learn in this particular exercise. Okay, let's look at them one at a time. So the first kind of quadrilateral is called trapezium. Now you are already introduced with what is trapezium in your class 8 mensuration. Okay, so if you don't remember, let's have a revision of what is a trapezium. Now I want all of you to observe these two diagrams. So these are the diagrams which you have come across in your daily life. Okay, so kindly look at this. Look at this dotted line. I hope you are able to see the dotted line. So this kind of shape is called a this kind of shape is called a trapezium. Similarly, here in this table lamp, this kind of shape. Okay, so this kind of shape is called a trapezium. Now, in a trapezium, what happens is two pairs of lines or sides are parallel. For example, this side and this side, they are parallel. Okay, and similarly in this side, in this diagram, this side is parallel to this side. Okay, so only two are parallel. Now the remaining sides, that is this side and this side, they should not be parallel. Okay, so only two sides has to be parallel and the remaining sides should not be parallel. So such kind of figure is known as trapezium. Okay, now let's have a look at three different kinds of trapezium. So first is this one. Now in this, as I said, these two sides are parallel, but here we see that the non-parallel side, these two are non-parallel sides. So the non-parallel sides are equal to each other. See, by the mark we understand that AD is equals to BC. So such kind of trapezium is known as isosceles trapezium. Remember what is isosceles triangle? Isosceles triangle is a triangle with two sides equal. Similarly, isosceles trapezium is a trapezium with two sides equal to each other. I hope this thing is clear to you. This is called your isosceles trapezium. Let's have a look at another trapezium. So in this trapezium, see, again, as I said, these two sides are parallel. They have to be parallel. But the non-parallel sides here, this one and this one, they are not equal to each other. Right? So this kind of trapezium is known as scalene trapezium. Okay, scalene trapezium. Okay, now next is this kind of trapezium. Now look at this. This trapezium and this trapezium, they are this side and this side, they are parallel. But here what happened is this side is making angle 90 degree with both the pair of parallel lines. Okay, so such kind of trapezium is known as right angled trapezium. I hope this thing is clear to you. Generally you see this kind of shape in a swimming pool. Okay, so if this is your one end and if this is your another end, then your floor will be slanted in a swimming pool. Okay, and this AD represents the surface of water. So this kind of shape is generally seen in swimming pool. Okay, I hope the shape of trapezium is clear to you. Right, so let's see some properties of trapezium now. So what first property is, the bases of a trapezium of isosceles, okay, are parallel to each other. So bases are parallel to each other, as I said. Next is the length of both the diagonals is equal. Now what is diagonal? I'm talking about only about this isosceles trapezium. Okay, so in isosceles trapezium, when you join AC and BD, okay, this AC and BD, they will be equal, and we call it actually diagonals. Okay, so AC and BD will be equal in case of isosceles trapezium. Right, so the next topic or next property is the diagonals of a trapezium always intersect each other. And that's definitely right. So when you draw the diagonals, they will get intersected at some point. Okay. Next is the adjacent interior angles in a trapezium sum up to be 180 degrees. Sometimes they will call you supplementary also. Supplementary means the pair of angles will give you their sum to be 180 degree. So here adjacent interior angles means adjacent means immediately next. Okay, so when you add this angle with this angle, okay, so they are adjacent angles, so their sum will be equals to 180 degree, and similarly the sum of this and this will be 180 degree. I hope this is clear to you. That's what you need to understand here. Okay, right, so we have got another last one. The sum of all interior angles in a trapezium is always 360 degree. Now all of you know that in a four-sided polygon we have sum of interior angles will be n minus 2, that is 4 minus 2, that is 2 into 180 degree. So 2 into 180 degree is 360 degree. That's quite obvious. Okay, right, so this is all about your trapezium. Now let's understand the next kind of figure, and we call it parallelogram. Now all of you are quite familiar with parallelogram, isn't it? So this shape is called parallelogram. Now you might get confused, what are all these notations? Okay, so we will understand this notations from the properties. Okay, so let's see some properties of parallelogram. So the first property says opposite sides are parallel. Okay, opposite sides means AB is parallel to DC. So this arrow, you see this arrow represents the sides are parallel. So this green lines are parallel to each other. Okay, and similarly this pink line, okay, so this pink line CB is parallel to DA. Okay, so they are also opposite. So opposite sides are parallel in a parallelogram. Next, opposite sides are congruent. Congruent means equal. Okay, so they are not only parallel but they will be equal also. So in other words, I can say that AB is equals to DC, and the other pair of opposite sides are BC, that is CB will be equals to DA. I hope this is clear. Okay, so you have to keep that in mind. So opposite sides are parallel and they are equal also. Opposite angles are congruent. So opposite angles are congruent means they are equal. So this angle is equal to this angle from the notation, and this angle is equal to this angle from the notation. Okay, next, same side interior angles are supplementary. It's the same case like that of your trapezium. So this angle and this angle, their sum will give you 180 degree. This angle and this angle will also give you 180 degree. Not only that, but this angle and this angle, if you add these two, they will also give you 180. And similarly, when you add these two angles, then also you'll get 180. So supplementary means sum of the two angles being 180 degree. Next, each diagonal of a parallelogram separates it into two congruent triangles. Congruent means equal triangles. So let's talk about only AC, forget our diagonal BD. So when you draw, see in a parallelogram, when you draw this diagonal AC, this will divide the parallelogram into two equal triangles. One is this triangle, triangle ABC, and another triangle will be triangle ADC. Okay, similarly, forget about this AC. If you draw only BD, then this BD will divide the parallelogram into two equal triangles. One will be ABD and another will be BCD. Okay, so two triangles will be formed and they will be equal. I hope this is clear to you. Let's have another property. So another property says the diagonals of a parallelogram bisect each other. So not only intersect, but they get bisected each other. So that means if they get intersected at point E, then DE will be equals to EB. Okay, so they get bisected. Bisect means to divide into two equal halves. And similarly, you will have AE is equals to EC. Okay, so from the notation you clearly see that. So that's all about the properties of parallelogram. Okay, so let's have another diagram now. So another diagram is rectangle. All of you are quite familiar with this, so I don't have to waste much time out here. So this kind of figure is called a rectangle. Okay, so what happens here is all the angles, all the interior angles will be 90 degree. That's quite obvious. Next is opposite sides of a rectangle are equal and parallel. In this case also they are parallel and equal. Similarly, AD is parallel to BC also, and they are also equal. Okay, now diagonals of the rectangle bisect each other. Okay, so diagonals will bisect each other. That's quite obvious. Okay, so basically rectangle and parallelogram both are same, because see, in rectangle also you have got opposite sides are parallel and equal, isn't it? And the same happens with parallelogram also. Okay, but the only difference is the opposite angles, I'm sorry, this angle and this angle, they will be different in parallelogram. Okay, so in a rectangle all the angles will be equal to each other and they will be 90 degree each. Okay, so you have to keep that in mind. Alright, very good. So let's move to next then. So next is a rhombus. Shape of a rhombus looks somewhat like this. Okay, so let's see some properties now. So basically opposite sides are equal, opposite angles are equal. Okay, so opposite angles, so angle A, this entire angle is equals to angle C, and angle B is equals to angle D. Opposite angles are equal. All the sides are equal and the opposite sides are parallel to each other. So if you look at the diagram, see, all the sides are equal, isn't it? So all the sides are equal, and on top of that the opposite sides are parallel to each other. Okay, so similarly BC will be parallel to AD. Kindly make a note of this. Okay, now next is diagonals bisect each other. Bisect is clear. We have already understood our bisecting the diagonal, but they'll get bisected perpendicularly. That means they'll get bisected at an angle of 90 degrees. So that's why you see all these signs are there. So angle 1, 2, 3 and 4, all of them are equal to 90 degree each. Okay, and remember this BD and AC, they will get intersected at O, and that will give you BO equals to OD and AO equals to OC. Simple, right? So we have next is sum of any two adjacent angles is 180 degree. The same thing like in parallelogram. So basically rhombus is also a parallelogram. Okay, kindly make a note of it. Rhombus is also a parallelogram, but in case of parallelogram all sides were not equal, only opposite sides were equal. But in this case, in rhombus, we have all the sides will be equal to each other. Okay, fine. So let's move to the next and the last kind of special figure, and we call it square. All of you are quite familiar with this. So this is a square. Okay, so let's quickly see what are the properties of square. So all the angles are 90 degree, we know that. All sides are equal and parallel to each other, we also know that. Diagonals bisect each other perpendicularly, same like that of the rhombus. Okay, so that's all about the properties. Now let's see few problems from your second exercise, that is exercise 14b. Okay, so the first question I'm taking is the question number 1. You just need to write whether it's true or false, so you can try that problem by yourself. Let's see these kind of questions. In the figure given below, AM, look at AM. So AM bisects angle A. So in this figure, this is angle A. This entire thing is angle A, and this AM is bisecting this angle. So basically, this angle, this much, is equal to this much. That's what is the meaning of this. And DM bisects angle D. So DM bisects angle D. So that's why this angle is equals to this angle. I hope you are able to understand the meaning of this symbols. Okay, so same kind of symbols means they are equal. Okay, now of a parallelogram ABCD, that means this, this ABCD is a parallelogram here. Now if they have given you parallelogram, then you have to think of all the properties of parallelogram. Now you need to show that angle AMD is 90 degrees. So AMD means they are talking about this angle. So this angle will be equals to 90 degree. That's what we need to know. Okay, now from the given figure, what we can conclude is, see, since this is a parallelogram, we know that the adjacent sum of the adjacent angles, that's angle A plus angle D, will be equals to how much? 180 degrees, isn't it? Right? So now let me divide both side by 2, because see, we have to bisect both angle A and angle D, isn't it? So since you are bisecting it, you have to divide by 2. So when you divide both side by 2, you get A by 2 plus D by 2 equals to 180 by 2 is 90 degree. I hope this is clear. Now from triangle ADM, so you see this triangle ADM. Now let's add all the interior angles. Okay, so when you add all the interior angles, this angle is A by 2, as I said. Okay, this will be D by 2. Okay, and this will be angle ADM. So add all of them. So some of the interior angles will be 180 degree. Now kindly look at this. How much is this? Just now you have found it that this is 90 degree. So in place of this, I'll write 90 degree. Okay, and from here you find that angle M will be 180. Bring this out here. So 180 minus 90 will be 90. So angle M is, they are talking about this. So therefore we see that angle AMD, that is this angle, will be equals to 90 degree. Right? So pause the video and note down your solution. Let's have a look at another question. So question number 3. So in the following figure, AE and BC are equal and parallel. AE and BC, they are equal and parallel. Okay, and the three sides AB, CD and DE are equal to one another. So that is also given in the diagram. If angle A is 102 degree, so this angle is 102 degree, find the angles AEC, AEC, and you need to find what is angle BCD. Okay, so BCD. So you need to find this angle and AEC. So basically we need to join EC. Okay, so what I am doing is I am not only joining EC but I am joining BD also. So when EC and BD are joined, then you have this kind of figure. Okay, now kindly observe the diagram carefully. Okay, so when you observe the diagram, let's observe quadrilateral AECB. AECB. So I am talking about this quadrilateral. Let's observe this. It is given that these two are parallel and they are equal. So obviously the diagram becomes parallelogram. So this quadrilateral becomes a parallelogram. So that's what is written. A is equals to BC. That's what is given. A is equals to BC. That is given. See, it is clearly given here. Okay, A and BC, they are parallel and they are equal. And obviously this AB and EC will be equal to each other. Okay, there is no doubt about that. And it is given that A is parallel to BC. So that's why we say that this AB will also be parallel to EC, and hence it is a parallelogram. Okay, so this is a parallelogram. Now you know that in parallelogram adjacent angles will give you a total of, sum of the adjacent angles will give you a total of 180 degrees. So that's why angle A and angle B, when you add them, you get 180 degree. Okay, so angle A is given to be 102. So from here angle B turns out to be how much? So bring this out here. So 180 minus 102 gives you 78 degree. So angle B is how much? Angle B is 78 degree. Now in a parallelogram, you know that opposite angles are equal. So I can say that angle B is equals to angle E, isn't it? So that's why we have angle A equals to angle E, that is this one. Okay, so angle A is equals to angle BCE. Okay, it's BCE. Kindly make correction of this. This is BCE, and angle B will be equals to AEC. Angle B is equals to angle AEC. Okay, so that's why what we can say is angle BEC, not BEC, again there's a mistake, BCE. Okay, so this angle is how much? 102 degree, because this is equals to angle A, and similarly this angle will be equals to angle B, which is 78 degree. Okay, so we got, see, our first answer AEC. So we got our angle AEC to be 78 degree. Right, so now consider triangle ECD. ECD. Now, as I said, AB and EC, they are equal. So in the same way, can I say that EC, CD and ED, are they equal? Obviously, right? So they are equal. So that's why we say that this is a, what kind of triangle is this? This is an equilateral triangle. And all of you know that in an equilateral triangle, the measurement of each angle is 60 degrees. So that's why I'm saying ECD. So this angle is how much? 60 degree. Okay, so that's why you know BCD. Okay, so question is asking you to write BCD. So BCD can be written as BCE, that is this angle. This is not BEC. Okay, this is BCE, plus you have ECD, that is this angle. So when you add this angle and this angle, you get angle BCD. So BCE is equals to 102, as you all know, and ECD is 60 degree. Okay, so when you add these two, you get 162 degree. So hence you have two angles, the measurements of two angles to be 78 degree and 162 degree respectively. So you may pause the video and note down your solution. Let's move to the last question for the day. So question number 4 says, in a square ABCD, diagonals meet at point O. Okay, so let me draw the diagram. So ABCD is a square, as you can clearly see, and the diagonals meet at point O. P is a point on BC. P is a point on BC such that OB is equals to BP. Okay, see here carefully. OB is equals to BP. So this one and this one, they are equal to each other. You need to show that POC is 22.5 degree, BCD is twice angle POC, and BOP is thrice CPO. Okay, so let's try to understand, or let's try to get the prove the things that are given in the question. Right, so let me take POC. Kindly look at POC. Okay, POC is this angle. So I'm considering this angle to be x. So basically we need to find the value of x, isn't it? Because question is asking us to prove that this is equals to 22.5 degree. Okay, right. So the diagonals of a square bisects, you know that. Okay, bisects the angle. Okay, so what is happening here is, kindly look at this carefully. Diagonals of a square bisects the angle. So this entire thing is how much? This entire angle is 90 degree. So this diagonal bisects the angle. So this becomes 45 and this also becomes 45. 45 plus 45 is total is 90. So that's why we have angle OCP. Okay, similarly this also. Okay, OCP, so that is this angle and this angle. Okay, both will be 45 degree each. Okay, this angle and OBP means this angle. So both angles will be equals to 45 degree each. Okay, now using exterior angle property, kindly look at this. Okay, so in triangle OPC, so we have OPC is this triangle. Okay, so using exterior angle property, what we can say is OPB. Okay, so kindly look at this OPB. OPB is this angle. So this becomes your exterior angle for this triangle. Okay, so this angle will be equals to sum of the opposite interior, that is this angle plus this angle. This is very important formula. Exterior angle will be equals to sum of the opposite interior angles. Okay, so OPB is equals to, kindly look at this, OCP. OCP means this angle plus POC, that is this angle. So the sum of this angle and this angle will be equals to this angle. Okay, now let's put the values. Now OPP we don't know, OCP is, you know, it's 45 degree. As I said, this is 45 degree, and POC, this is taken to be x degree. That was the assumption that we made. Okay, now kindly look at this carefully. In triangle OPB, that is this triangle, this angle and this angle, they are equal to each other, isn't it? No, I'm sorry, this side is equal to this side, because it is clearly given out here. So what kind of triangle is this? This becomes isosceles triangle. And in an isosceles triangle, you know that this angle and this angle, they have to be equal to each other. So that's why I have written angle OPB equals to angle BOP. Okay, now BOP, so that's why you see, you know that OPB is 45 plus x degree. So that's why we can say BOP is also 45 plus x degree. This is from equation number 1. Okay, now you know that the diagonals of square are perpendicular to each other, isn't it? Kindly see this carefully. Okay, so the diagonals of the square are perpendicular to each other. So this, when they get intersected, this entire angle, this entire angle, this entire angle, and this entire angle, they are 90 degree. So that's why we can say BOP, that is this angle plus this angle. So altogether this will be equals to how much? 90 degree. Now BOP is 45 degree. BOP is 45 plus x, and POC is x. So from here you get the value of x to be 22.5. And what is x actually? X is the measurement of angle POC. So that's why angle POC will be 22.5 degree. So you can call 22.5 as 22.5 also. Okay, right. So the diagonals of the square bisects the angle, as you all know. Now, so that's why angle BDC. Okay, so B, kindly look at this, BDC. So I'm talking about this angle. So this angle will be 45 degree. See, this entire thing is 90 degree. So that's why this becomes 45 degree. Okay, now 45 can be written as 2 into 22.5, and 22.5 is nothing but POC. So it becomes double of 45 degrees, double of angle POC, isn't it? So that's why I have written angle BDC is double of angle POC. And the last one is angle BOP is 45 degree plus x degree as per this equation number 2. Okay, now the value of x, all of you know the value of x is how much? It's 22.5, right? So this is double of POC. All of you know this is 2 times POC, and this is equals to angle POC. So double of POC plus POC will be equals to how much? It will be 3 times POC. Okay, POC, and that will be in turn will be equals to CPO. I hope this is clear. Okay, so we have now the third part being proved out here. Okay, so you may pause the video and note down your solution. So we will do only this much for the day. Thank you very much.